Good morning, everyone. My name is Kusha Kang, and my supervisor is Dr. Noor Hidayah binti Zainab. And we are from University Technology Malaysia. So today I will giving a presentation about the topic biocap nanoparticles for produced water treatment. So today our world is facing a problem is the oil and gas industry actually produce 250 million barrels per day of dirty water. Then it contains the oil, salts, and toxic organics. And then this actually more saltier than the seawater. So why currently the methods is fail to solve this problem? Like the chemical is very expensive and then actually also make the new sludge waste and then the membranes is clogged easily. Then the thermal treatment is actually produce very high energy cost. So what's our new innovation is to use the magnetic nanoparticles like the iron oxide to coat with the natural biopolymers. This actually can stick to the oil or the dirty and then to be pulled out with the manex. Then this method actually is more fast, reusable, and eco-friendly. So this research proposal how to relate to the SDG 6 and 12. So to related to the SDG 6, this research proposal actually use the biocap nanoparticles to remove the oil, salts, and organics from the produced water to making it more safer and then enables the reuse of treated water in the oil fields, reducing the freshwater demand. So for the SDG 12, this research proposal actually using the nanoparticles that can be recovered and reused for the further 5 until 20 cycles and then produce the less waste. And then the oil collect during the cleanup can be recycled and sold instead of waste. So this shows the connection to the SDG 12. So I will like to talking about the further for the methodology part. So for the methodology part can separate for the four phase. So the first phase is the nanoparticle synthesis and characterization. So actually for the nanoparticle synthesis is to make the tiny iron oxide particles. It's like and then we will test their size, shapes, and then magnetics, and then also the stability. And then for the biopolymer coating, we will cover the nanoparticles with the natural materials like the chitosan, and then alginate or mix. This make them more sticky for oil and safe for the environment. And then for the treatment part, means the third part or maybe the third phase, we will try to use the nanoparticles on synthetic and real wastewater to measure the oil removal, organic pollutants using the TOC test, and then the speed of the cleanup, and then of course to measure the effect of pH, salinity, and ions. So for the last step of the methodology is the magnetic recovery. We will use the magnets to pull the nanoparticles out quickly. And then we will test also the recovery efficiency and how many times they can be reused. Like a range in the range 5 until 20 cycles. And then of course try regeneration, the methods. So for the recommendation part, I would like to talk about is we will start with the lab studies first. After that, the further step is to pilot test and then, of course, the full scale. But we will focus on the offshore and sensitive area first to engage the regulars easily. And also, we'll work with the equipment manufacturer for the magnetic recovery system. And we will also recommend to do the environmental safety studies to prove that this method actually is no harm. So for the discussion part, I would like to focusing on the performance is these methods can remove 83 until 98% of oil quickly. This is a minutes to the hours range. Then this actually is better than the membranes. And then for the environmental impact, is no need for the toxic chemicals. And this actually using the reusable nanoparticles, this actually can produce a less waste. And then for the economic benefits, this actually is more cheaper than the traditional methods. And then the oil recover can be resold again. So this also brings the more benefit from the economic scope. So for the conclusion, I would like to conclude that these biocap magnetic nanoparticles are a game changer for treating the oily wastewater. They can clean the faster, safer, and cheaper than current methods. And then this method actually support the sustainability, zero liquid discharge, and circular economy. So thank you for listening for my presentation.